Hello everyone and welcome to a video where I'm going to be teaching you how to make a REST API in C++ because that's the language we all care about. I know you might know how to do it in Node.js or Python or maybe even Go or Java, but all that is crap. No one cares about it. We want C++. So that is what we're going to be doing today. We're going to be coding a REST API in C++. And if for some reason you don't know what that is, and you still stumble upon this video, REST API is just an API, which is like an interface. So it's basically a web interface to interact with server and eventually interact with the data that is stored in database. So to do that, we're going to be needing a library. Like in JavaScript, you need Node.js and Express. Here, so Node.js is a runtime. I meant like Express. So here we're going to be using this crowcpp library. So it is a pretty trendy library on GitHub at least. So we're going to be using this, and this will be for managing the HTTP requests, routing, and all that stuff. It also has logging actually. Every C++ library has logging, to be honest. And other than this, we also need a database. So because I don't wanna I didn't want to code SQL or MongoDB client, and so what I did is I'm gonna use Redis as a database because that's what I found the easiest. And so this will be our database, Redis, and crowcpp will be our library or framework for coding the routes and everything. So first of all, how to install it. So if you go to getting started, based on whatever system you have, if you have Linux, just install Boost. If you have Mac, again, just install Boost. If you have Windows, may God help you. Actually, you can try to navigate VCPKG. So it's for Visual C++, I think, or you can just use Windows WSL and do the Linux way. I have a Mac, so what I did is brew install Boost, and then my library was installed somewhere around here. So if I go user local homebrew seller here, as you can see, I have the Boost library installed. Inside the include, I have the header files, and inside the lib, I have the library. Now, this is the library that is required for crowcpp to run. After you have done that, what you have to do, so let me just close this. So I was actually running this. Now what you need to do first of all is, so this is gonna be our structure. Forget build VS Code. We're gonna make a dependency folder, and inside that, so clone this repository crow. So that is as simple as git clone. So that's all you have to do. And once you do this, we are gonna now add it to our project using a build system called CMake. Now C++ does not have anything like npm. That is for soy devs. We do everything by hand. Okay, so we're gonna be adding that to our CMake in a second, but before that, let's also get this cpp redis library. I'll leave all the links in the description, so don't worry. And if you go to its installation guide, that is somewhere here. So yeah, if you go here, that's all you have to do. You have to go to your uh, dependencies folder and then say git clone recursive this, so that you also clone the some modules. And then once you have done that, we have the libraries and all the dependencies for those libraries. That was mainly Boost. Now we need to add them to our build file or the project. So we are gonna have a main file. I'm gonna tell you how this works in a second. Okay, what happened here? Don't save. But first of all, let's make a CMake file. So we're just setting the minimum CMake required version, the project, this random stuff that I got from the boilerplate. Then set the C++ version 17. So that's what we're setting here. And now, first of all, what So what you need to do to add a C++ library in your project is add its header files, the includes, and the library if it has that, if it has definitions. So how to do that? um, First of all, let's say we needed to add the boost library. Because this path was not in my compiler paths, I had to add it manually. So this is for boost. And then and similarly I also had to add this library path. This is for pthread, I think. And then after we have added the include directory, actually forget this for a second, this is for link directory. I don't know why I have it here. So first of all, add the includes of boost, and then we link it using target link libraries boost system. Now pthread is also in my system, but it doesn't know where it is, so I had to specify the link directories. And also because yeah, so for that I had to do this. And so then I can add target link libraries. Then now let's add our cpp crow. So for that also we first of all specify the include directory. So our current directory, that is CMake current source directory slash dependencies slash crow slash include. Okay, my tongue slipped there. And then similarly for cpp redis, current directory dependencies cpp redis includes. And then since okay, wait, I think both of them have, yeah. So since crow does not have any definitions, it's a header only library. I mean, it obviously has definition, but it's a header only library, so we don't need to link that. We just need to link cpp redis. And now that everything is linked, we also add the executable and then just other random boilerplate. So this is our CMake. So let me just remove all the changes. So this is our CMake file. Now what this will help us is make sure you have installed the CMake extension if you're using VS Code, or if you're using CLion, then I think it will be easier. But it will help us to just run by using this command. And now let's have a look at how actually we implement our library. So I mean our REST API. So to do that, first of all, create a simple crow application. And this is from the getting started guide, and also this place. So if you go into crow examples, and here in the example all, so most of the stuff I've taken from here. So okay, let's have a look where I was. Main.cpp. So first of all, let's make a simple route here. This is a get route because we have not specified anything. So a slash health. So anytime someone will hit this route, they will get working fine. And if we don't, then we know that our server's health is not fine, it's not working. So let's actually test that. If I do curl localhost 3000 health, okay, I need HTTP. Okay, first of all I need to run this. So to run this, I just did run without debugging. Other way to run it is also manually CMake dot and then run the build file. I have actually left the instructions. So yeah, if you want to build manually from terminal, you have to do CMake dot dot after this, and then make, and then run the executable. So if I do this HTTP request, I get working fine. So we have a health route. Now let's see how we can do get and post. Because for get and post we need obviously we are gonna want some data. I am using Redis as a database. Now if you want Redis quickly, what you can do is, instead of installing Redis client on your machine, what you can do is I mean, you're still gonna install that, but in a roundabout way. First of all, install Docker. That is as simple as installing the Docker desktop application, and then what you have to do is Docker run this. So run with name Redis local and expose the 6379, that is the default Redis port, and it is in detached mode, and we want to do make a Redis container. So once you do that, you will be able to run a Redis server locally in a totally containerized environment. And since I already have that, I can do this to run my Redis server. Now I know that it is working by using this command redis CLI ping. I get pong. Okay, so let's have a look at how our get and post work. Now we can obviously replace this Redis with any other database, whichever client you find useful. I didn't want to deal with SQL in this small project, so I didn't use that. So to define a post route, we again use the crowroute macro and then specify that the method is post, and we're gonna take in the parameter request. So now what we're gonna do is load the body using JSON load, and if body is invalid, then we are gonna return a 400 response with invalid body. So let's try that. If I do curl x post, so I was trying this, that it is working because I didn't want to record with half things broken. So blogs, if I just run this, as you can see, I got an invalid body. Now what I'm going to do is, if I were to send a valid body, and that is JSON, so we have to send that content type is JSON and data is this. So how to get that? It is as simple as accessing something from a map and then calling the .s function, which returns the string value. Similarly for content, so if we give both of them, we're going to get title and content. If there is any unexpected error, we are just going to return invalid body. So for example, if instead of content I were to send something else, I still get invalid body. And now I need to save it into my database. So what I do, so the way my database is, since it is Redis, it is like I have a key titles and then an array of titles. And then similarly what I have is contents, and that is array of content, and their indices determine which title belongs to which content. So that's corresponding to whatever. Now so that is why I just list push into titles key this title array. So it just takes in a standard vector, and that is why I have this braces around. Similarly push to contents and then commit. So if you don't know, in Redis there is this thing called pipelining, where every command you say doesn't immediately get sent to this Redis server. Instead we batch them together and then send them, because to save network bandwidth basically, and network latency or whatever. Not bandwidth, I mean latency. And then we commit it in a synchronous manner. We can also do an asynchronous commit. So I think yes, that would be asynchronous, I think. Anyway, so we synchronize, so we commit it, and if there is any error, we return internal server error. And however, if that works fine, we return a blog added response. So let's try that. If this was a content, new C2, new T2, and as you can see, we got a blog added. Now let's see how the get request works. So for get request, we just have to specify this much. We don't have to tell the method, that is by default. By the way, you might be wondering why I have capture by reference, because I want to use Redis client here. Anyways, so inside it, so first of all, I need to get all the titles and blogs, right? Because this is a get all API, it's not a get by ID or something. So we get all these titles and content. So L range gives us title and content. 0 is the starting index and this is the last index. Since it is -1, we'll get everything. Similarly for content. So pardon my bad naming here, I was in a hurry. So again, sync client, sync commit. So send this to the Redis server and wait for the response. And because we get a standard future here, we have to wait on them. And now the response we have are R and RC. So this is the response reply for L range titles, and this is for L range contents. Now what we have gotten uh, in r1.get is a reply, but this is a range, right? We will get multiple replies actually. So what we can do is get it as an array. So we can get it as a string as well, but then we won't be able to differentiate what which title is where. So that is why we first of all separate it out into the actual replies. So reply is just basically what Redis sends back, and then we create a standard vector for strings containing the actual titles and contents. And the way I get them from this array to this array is by a standard transform function. So transform this range from r begin to r end using this lambda and put it into this iterator, and then keep incrementing it. So basically transform every element of r1 using this lambda and put it into titles. And what I'm doing is simply getting the string value of that reply. And again, similarly for the contents. And now that I have the titles and content, I have to convert it into a JSON. So to convert it into a JSON, so W value is just a writable value or something like that. As you can see, primarily used for assemble JSON objects. Yeah, primarily used to assemble JSON objects. So to write to JSON, and we have a vector of that. So one JSON object will have a title and a content. So we just add all of them, and then we finally return a JSON object where data is the standard vector of this. So it is like we have a JSON title and content, and then we have an array of this. That is what standard vector tells us, and then this is sent as data in the final JSON. So I know this is really clumsy. I'm not sure if CBP Crow has ways to bind some JSON to a struct. That would be very useful. That's the way I like it actually. That's how we do it in Go as well. But this is a simple way to do as well. Anyways, okay, let me just remove that. And then we just send it. So let's have a look at if I were to send it. Sorry, if I were to do a GET request. So I'm just gonna copy this. All right, copy. And as you can see, we have gotten some response. Let me just use JQ to format it. And yeah, as you can see, the title and content we added is at the top, and then all the old titles and content. And there you go. You have a CRUD API. Create, read, update. For delete, again, we can just do it normally. But yeah, our basic REST API is done. And obviously it is 100 times faster than anything you can write in JavaScript. No cap. Why would I lie to you? Does it look like I'm biased towards C++ at all? No way. Anyways, with that said, I just wanted to take a moment here and talk about why we shouldn't do this. I know I wasted 1 day from 2 weeks ago, 1 or 2 days. I think it was in 1 day from 2 weeks ago to write this. But practically it's not that useful, because if you want performance, Go and Java are already pretty performant. JavaScript is also not that bad. But the thing is, in these REST APIs, mostly what happens is you do asynchronous calls to other things like other microservices or database or something like that. And those are the real bottlenecks, because they take network latency. So that is why code efficiency is not really that much of a concern in most APIs like this. However, if you are making a one, that requires heavy computation, then C++ is actually not a bad choice in my opinion. But should we use Crow? I'm not sure. I mean, it's a great library, and I would love to see it being developed more. I actually wanted to contribute as well, but I wasn't getting any idea what should I do. And then I got busy with my internship at Google. But I had to mention at Google. I just had to. That's the law. Anyways, but what I think is a better way is to make a gRPC service. So gRPC is also like HTTP. So here, as you can see, uh, we have to hit an HTTP endpoint, and then basically this function is being called, right? This lambda. What RPC is that we don't hit an HTTP endpoint. We just hit a like an RPC endpoint, whatever that is, right? Now, obviously, that is uh, on the web, so we have to communicate with it somehow. But what happens after that is that we directly call some method. So it's like I will have a method, something like a function. We'll have like let's say void post blog and whatever the contents are, so title and content, something like this. And we're basically just calling this function. We are not even hitting a HTTP route, and where we have to first of all load the JSON, do the validation, all that stuff. This function is directly called. So this function, also known as a procedure, is remotely executed. That is what remote procedure call is, RPC. And gRPC is a very good abstraction over it, and it has pretty much all major language support. So if we go to gRPC docs, you can check out here how you can build a gRPC server. So here, as you can see, first of all, we define everything, like what. So this is like a struct, this is also struct, and this is a like a route. So there's a say hello function that can be remotely executed. So this is like RPC endpoint, and this is say hello function that can be remotely executed, say hello again function. And then using that we generate some code, and then we inside that code write what we need to do. So the logic then goes there, and then we can just like run it somehow, whatever the way it is, and then we can just hit it whichever way using our RPC client. And RPC actually communicate using protobufs, and those are much more efficient than JSON. So what I'm saying is, in case you are actually needing C++, you're probably wanting a lot of performance. In that case, might as well prefer a gRPC. But this wasn't half bad. This was pretty fun to actually do. And actually, and this is obviously faster than what you would write in Express, because it is C++. There's also some benchmarks. I wanted to go to GitHub, right? So there are also some benchmarks which shows its superiority. As you can see, Crow is pretty amazing, but obviously it is not that full-fledged. But it is a very promising framework, and I would definitely consider using it for a non-serious project for fun. And that is why I shared with you all this. It's just my opinion that if you are making a service using C++, might as well use RPC. However, if it is a user-facing service, then we will need HTTP client, and then this is not a half bad client. It is pretty good actually. So yeah, that is it. Hope you guys liked this video. If you did, leave a like, subscribe, and I'll see you next time.